Hi, in this lecture you learn how to use the DHT11 sensor. This is the blue sensor that you see already attached, plugged into my breadboard here. So the DHT11 is a very popular sensor, very easy to use, relatively low cost as well, and it gives out temperature and humidity information in digital format. So digital reading means that the information that you get out of this sensor is already a number. It's not a voltage level that you then need to convert into a temperature reading as you would with an analog sensor, such as a thermocouple, for example. There are many ways by which you can measure temperature. And as I said, the nice thing about this sensor is that you don't have to do any conversion. The numbers that come out of the sensor are already calibrated in the factory and fairly accurate as well. It's not the most accurate sensor. There are more accurate sensors than this, but this is a very good sensor that balances the cost with the accuracy. Now, as you can see, there are other similar sensors, such as the DHT12. Actually, you can probably see the markings on the package of this sensor right here. This is the AM2302, which is a sensor that belongs essentially to the same family as the DHT11. They use the same communication protocol to work with the Arduino. So very often you'll see software-wise that a library, as you'll see in a moment, a library that works with the DHT11 can also work with the DHT12 or with the AM2302 and a few other members of the same family. So in this course, we use the DHT11 that comes with the SunFounder 3-in-1 Arduino kit. And before we go to have a look at other documentation information and the sketch, I want to talk quickly about the pins of the sensor and how to connect them to your Arduino. So this sensor has 4 pins. And as you are looking at the sensor with the grill towards you, the first pin on the left side is the power pin. So that's what you connect to 5-volt power. And I've done that here on the breadboard with this short jumper wire going to the 5-volt power rail. The pin next to the 5-volt pin, this one here, is the data pin. You can connect this pin to any digital pin on the Arduino. In my case, I have connected it to digital pin 11. The next pin, the third one from the left, is left unconnected. It doesn't do anything. You can cut it off or just not connect it to anything and it's going to be okay. It's the same thing with the DHT12. The third pin is not used. It's just there for show, I guess. So you can leave it unconnected. And finally, the last pin here on the other side of the VCC pin, the 5-volt pin, this is ground. So in my case, I have connected it to the ground power rail via a short solid core jumper wire. It goes to Arduino ground. All right. Another thing to remember here is that very often these sensors, because they're low cost and depending on where you purchase them from, they are unmarked. So you can see this package here doesn't have any writing. It doesn't really tell us anything about what's inside this packaging. The documentation that comes with the kit from SunFounder, of course, tells us that this is an DHT11 sensor, but if it wasn't for that documentation, there's nothing on the package that is telling us about it. So it's important for whichever library you are using to be able to automatically detect what sensor it's talking to so that you don't have to go through a long list of possible options in the constructor of the sensor object until you find the one that actually works and produces valid results. So this sensor works very well with the DHT new library because it does have the capability to detect which sensor we are using in our circuit. All right, so I'm going to plug the sensor back onto my breadboard. Being careful to connect the pins correctly. And there you go, good to go. Now let's have a look add some additional documentation information and the demonstration sketch. On the SunFounder website, you'll find the pins and the pin layout for this sensor. As I said, this is identical to the DHT22 sensor, which is an upgraded version of the DHT11. It's a little bit faster with a little bit more accuracy, but both of those sensors provide us with temperature and humidity information. So here's another schematic, and here's how to connect it. And of course, I've got this information here in my notes as well. This is the schematic wiring that I have used for this experiment, and the data pin from the DHT11 goes to digital pin 11 on the Arduino, but you can use any of the other digital pins as well. It's not a problem. Now, if you search Google for libraries for the DHT11 and 22 sensors, you'll find a lot. There's many libraries that allow you to use the DHT22 without having to worry about its peculiar and proprietary protocol that is using for communications. The library that I really like here is called DHT-New, and it's written by Rob Tillard. It's a very good library for many reasons, so I'm explaining here. It has automatic sensor type recognition, so you don't have to know what sensor you're plugging in. Another thing that's very good here is that it's got a built-in error or fault detection. So what happens often is that if the sensor is damaged, you're not going to know unless you have written some code to try and figure out the fault condition. And again, this library will do that for you. The library works with many sensors that use the same protocol, and looking at the documentation here, you can see there's quite a few of those, the DHT11, 22, 33, 44, and so on. And this library can work with all of them. And of course, it can detect all of them. And there's other interesting features, of course, such as the ability to tell you how long it's been since the last reading, so that you know that the latest reading that you have is like a fresh reading. So all around, this is a very good library. I recommend that you use it, of course, but just remember that there are many other libraries out there that are also very good. Now, in terms of the sketch, this is a very simple sketch that I have written drawing from the library itself. So if you go to the library, you'll see examples. There's a lot of examples here. Some of them are a little bit more complicated than others. And if you look at the Arduino IDE, you go to examples, and down here is DHT new. You'll see those examples. So for example, if I go for the DHT new _ test, this library example looks like this. It's basically a demonstration of various features that are available through the library. But I wanted to simplify things and came up with the simplest possible example sketch for this lecture. So what we do here is we include the new library. If you haven't installed it, then go to the library manager, type in DHT new, as this one right here, and install it if you haven't installed it already. I'm using version 0.418 when I record this lecture. So put that away, then define the pin that you have connected the data pin of the sensor to. In my case, it's 11. Then I'll use the DHT new constructor to create the my sensor object, pass the pin through as a parameter. Inside setup, I start up the serial monitor, print out a few test messages, including the type. So I'm using get type function to print out the type. You'll see 11 printed after the word DHT, or the initials DHT. And finally, in the loop, every 5 seconds, I use the read function to take a reading and then print out the humidity and the temperature. The second decimal in the print function is just how many decimals I'd like after the point. So I'll be doing 1 decimal point. All right, upload the sketch. Okay, open the serial monitor. There's the 11 from the auto detection. system in the library, and there's humidity and temperature readings coming out. I wonder if the plotter works. Waiting for one more value. Yeah, it does work. So I've got the temperature, which is the orange line, and the humidity, which is the blue line up the top. There's not very much variation here because the values as they're coming out are very close to each other. Okay, and that's it with the DHT11. We'll be using the DHT11 to get temperature and humidity sensor readings and sending them to the Blink dashboard in lectures and sections that are coming up later in this course.